Hello class, today we're going to be talking about biomolecules. We're going to take notes on page 19 and we're going to do an activity in our output called You Are What You Eat on page 20. So please go ahead and write that down, and when you're ready you can flip to page 19. So the first part is going to be a little bit difficult. You're going to need a ruler or straight edge, and actually I'm going to turn this. You will need to create a table like the one that I have created. You'll notice that there's 4 lines across and 3 lines down. I use the margin as my first line for my biological molecules or biomolecules, and then all of the titles are above that first line. The spaces are about 2 inches by 2 inches after that, roughly. So go ahead and pause it and make your table. You can even add the headings if you would like. Let me see if I can pull this down. Okay, so you can go ahead and pause it right there and fill in the table, and complete the table the way it is, and then we will fill it in together in a moment. So one thing you'll notice is the title. It says biomolecules. AKA just means also known as macromolecules or organic molecules. If we were to look back at our previous pages notes, you'll see that I've drawn an example of a biomolecule here, and we talked about how non-living things would stop here at molecules, but living organisms go all the way through these various levels. So we are going to talk about specific types of specific types of biomolecules. The 4 biomolecules we're going to be discussing today are lipids, also known as fats, proteins, carbohydrates, also known as sugars, and nucleic acids. We're going to, in addition to going over the biological molecule itself, we're going to talk about the purpose of it. Why does it exist in our body? What does it do? What do these molecules do? What is the shape of the molecule, and what is its monomer? Monomer is like a building block. Like, what makes the biomolecule? What is it? What are the smaller components? And then what are some examples of where these biomolecules can be found in our life? So let's start with lipids or fats. It's fairly common knowledge that fats provide some sort of energy for us and our bodies. So it is actually important that, low-fat diets are all the rage, but your body does need some fat. So the purpose of, or one of the purposes are long-term energy. This is particularly important to note that this is long-term energy. So your body is actually going to burn through carbohydrates, a shorter term of energy, before it starts to pull from long-term energy. So this is the storage form of energy. And in fact, if you think of fat on the body is simply stored energy, stored fat, stored lipids, which you could burn. It's also storage, in addition to storage and long-term energy, fats also provide insulation and protection. So you would have a harder time maintaining homeostasis if you did not have some sort of fat on your body. And it's protection, and primarily protection for your organs. It's important that your body has fat so that it stays safe and maintains homeostasis. So the monomer, or the shape of this, is essentially it's built with a what's called a glycerol. And then it has what's called fatty acid tails. So if you were to look at these, this is roughly what you'd see. I'm just using this to show you that it's usually 3, because normally the monomer of a standard typical fat, a lipid that we would consume, is called a triglyceride. And a triglyceride, tri meaning 3, so that's a hint that there's 3 tails. Glyceride comes from glycerol, and triglyceride is the monomer, the small building block that makes up these fats. Okay. There are many examples of fatty foods. You've probably heard of many of them. There's any kind of oils, butter, lard, all the good stuff that makes things taste nice. But there's also some things like avocado, which is it's not only made of fat, but it's super high in fat, as well as nuts and meat. And of course, this list could go on. We could add, cheese and all kinds of other things that are high in fat. So you'll notice I put meat here. A lot of people are like, oh, meat I associate with protein. Yes, meat does have protein, but depending on the type of meat you eat, there's a good chance it's also high in fat, depending, especially red meats. Okay, proteins are important to literally almost every single thing that takes place in our body. They do so much. I could not possibly list all the things they do, so I'm just going to list 3, and you'll just have to trust me when I say they do so much for us. So the first thing they do is they provide actually the structure for our cells. So they actually give it its shape and its structure. Also helps with what, and I'm sure you've heard before, athletes tend to eat a lot of protein, and that's for muscle development. Some of them might even take supplements. To hyphenate that, to make it fit. And then lastly, it is very important for our immune system. As I've said though, could go on and on about this and proteins and what it does, what they do, but let's stop there. Proteins are typically composed of what we call amino acids. They're pretty simple looking. They tend to just be strands, long strands. The number depends on the type of protein it is. We call a set of them amino acids. That's the monomer. Amino acids. So these are what a lot of people call the building blocks of life, because these are so essential to who we are. Proteins are, like I said, they do so much. Okay, so I want to put meat at the top of this one, because obviously meat is one of the primary biomolecules that make, protein is one of the main biomolecules that make up meat, but you can also find it in dairy products, eggs, legumes, nuts as well. And you could go on and on, honestly, with that one too. So many things are high in protein. Sorry, this is shaking. I'm not sure why it's doing that. Okay. Moving up to carbohydrates. Carbohydrates, it's just a fancy way of saying sugars. There's different types of carbohydrates, but we can talk more in detail about that a little bit later. So the primary purpose is just short-term energy. So you might have heard athletes say, oh, the night before a game, I'm going to eat a giant bowl of pasta. And the reason for that is usually so that the next day they have this wonderful short-term energy to work off of, which they'll burn before they start burning their fats or lipids for long-term energy. Carbohydrates are composed of what's called monosaccharides. which tend to be 5 or 6-sided figures. And they can kind of string together. So this one's a monosaccharide because it's just one. Mono actually means one. So mono equals just one of them, but you could also have, sorry, let me actually write that differently. Mono equals 1. Disaccharide is 2 strung together, and then anytime it's more than 2 of these put together, we call that a polysaccharide. It's pretty basic shape, but it's obviously a much more complex molecule than that. These all tend to be called macromolecules, and that's because macro means, you know, large or expansive. So these tend to be longer strands joined together, complicated, complex, as opposed to a single molecule, which tends to not be quite as complex or large. Okay, carbohydrates. So I've already mentioned one, which is pasta. Who doesn't love pasta? But there's also bread. Oh my gosh, these are, I think carbs are my favorites. Any kind of like sweets really that you have. These aren't, obviously sweets aren't necessarily going to be the best kind of carbs. These are definitely harder for your body to process. Bread, well, it depends on the type of bread. You can get whole grain breads, which are really good. Particularly easy for your body to process. Same for pasta. But you could also have some pretty bad varieties of them that your body doesn't particularly get along with so well. And most people are surprised to hear that fruit and vegetables are very high in carbohydrates, but they tend to be, like I said, healthier or easier for your body to process. Very good nutrient-rich forms of carbohydrates. That's why we always encourage people to eat those. Your body needs them for energy. And you're going to feel good if you eat foods high in good carbohydrates. Okay. Lastly, we have the one you may have not have heard of before, but it's called a nucleic acid. Nucleic acids, the word deoxyribonucleic acid, you can hear nucleic acid in there. That's the long word to describe DNA, so, or RNA. So you've probably heard at least that component of it. The purpose of nucleic acids is actually to create our DNA, our genes. It's our cellular instructions. So this actually tells our cells what to do and forms our DNA and RNA. And then it also is responsible for like passing down our traits, our heredity. It's responsible for evolution. Nucleic acids are extremely important. You don't typically say, oh, I need to eat lots of nucleic acids. That's because everything that is living is made of cells and therefore has DNA and therefore contains nucleic acids. So it actually doesn't matter what you eat, it's going to have nucleic acids. The monomer for nucleic acid is actually called a nucleotide. So pretty basic shape, kind of similar to a carbohydrate in that it's pretty basic 5-sided figure, but then it has various components, bases, and we'll talk more about these later. I don't want to confuse too much on that account. The monomer is actually called a nucleotide. So one piece of, okay, and the last section, which my video cut out, so here it is. Anything living or once living, also known as dead, would go in this examples category. Okay, let's take a look at our output for this activity. It's pretty straightforward, but it's kind of fun. And one of the things I want to emphasize is that biomolecules it actually comes from what we eat, and our body takes what we eat and what we consume, those nutrients, and it fuels our body, and that's how we function. So that's why you start to feel really weak when you're not eating. Your body is struggling to maintain homeostasis, to find balance. So this activity is called You Are What You Eat. Like I said, just want to emphasize it. So let's do it. It's kind of fun. So you're going to list out some favorite foods. I've put a place for 5 here, but you can list out more than that if you'd like. And then all you're going to do is draw a picture of what you would look like if you really did become what you ate. Please add color. You don't actually need to write down these instructions. You can simply make your drawing. As an example, let's say I wrote spaghetti here. I could add a person-like figure here. Maybe the hair is made of spaghetti strands, spaghetti noodles or something like that. Have fun with it, be silly, add color, don't take it too seriously, but also take your time and make it look really neat. Reach out if you have questions. Thanks.